Hey everyone, and welcome to This Explainer. If you're an apprentice or an electrician gearing up for the NEC 2023 exam, you've probably realized by now that the National Electrical Code can sometimes read like it was written by lawyers strictly for other lawyers. But we're going to change that right now. Today, we are completely ditching the dense code speak. We'll use Article 90 as our foundation, and we're going to translate the heavy-hitting rules of Articles 100 and 110 into real-world, everyday job site knowledge. By the time we wrap up, you're going to have the exact numbers, thresholds, and definitions you need to absolutely crush your exam.
So here's our flight path for today. We're going to cover the path of power, nail down some key definitions, look at working space rules, tackle installation specs, and finally, expose some of those sneaky exam traps.
All right, let's jump straight into Part 1, the path of power.
You know, the NEC doesn't actually want you just memorizing wire types completely out of context. It categorizes them based on the job they do. Let's break it down into steps. Step 1 is the service. These are the conductors delivering energy directly from the street utility to your main disconnect. Past that disconnect and head toward a subpanel, well, now those wires become your feeders. And finally, Step 3, the wires running from that very last breaker right out to the receptacle where you plug in your drill. That's your branch circuit. If you lock in this physical flow, these massive Article 100 definitions are going to become completely second nature.
Moving right along to Part 2, key definitions.
Okay, first up, let's talk about the word accessible. The code defines this as admitting close approach, which basically means it's capable of being reached without removing permanent building structures or finishes. A perfect field example of accessible would be a junction box or wiring tucked up inside a drop ceiling. Like you can get to it, sure, but you might need to go grab a ladder or pop a ceiling tile out of the way first to actually do your job.
But watch out, because here's exactly where they try to test you. They love to compare accessible to readily accessible. The crucial point for the exam is that single word, readily. If an inspector or an exam question says a piece of equipment must be readily accessible, like a main disconnect or a breaker box, it means absolutely zero climbing on ladders, no using tools to pry open panels, and definitely no moving a giant mountain of cardboard boxes out of the way. You have to be able to walk right up to it and operate it instantly.
Now, here's a number you just have to burn into your brain. 3 hours. If a load is expected to run at its maximum current for 3 hours or more, think of, say, a commercial parking lot lighting system that clicks on at dusk and runs all night long. The NEC officially calls that a continuous load. This one single definition drastically changes how we size our wires and breakers later on.
Let's do a quick rapid fire on a few other critical Article 100 terms to really anchor these concepts before we start installing physical gear. Ampacity is simply the absolute maximum current a conductor can carry continuously under its conditions of use, without overheating. A dwelling unit? Well, it isn't just a room. The code specifically says it must have permanent provisions for cooking, living, sanitary, and sleeping. Honestly, if it's missing a kitchen, it's not a dwelling unit. A qualified person is a major one to know. It's someone who doesn't just have skills and knowledge, but explicitly has received the safety training to recognize hazards. And finally, listed just means the equipment has been evaluated by a recognized testing lab, like UL.
All right, on to Part 3, working space rules.
So Table 110.26A1 is all about your working space depth. And notice how the requirements jump up depending on two things: the voltage to ground, and what is sitting immediately behind you while you work. Condition 1 is exposed live parts on one side and totally empty space behind you. Condition 2 is live parts on one side, but a grounded surface behind you. And Condition 3 is definitely the most dangerous: exposed live parts right in front of you and right behind you. Notice a cool trick here? For standard 120-volt systems, which fall in that 0 to 150-volt column, the answer is always 3 feet, literally no matter the condition. Let's ground this with a field example to make it stick. Imagine you're working on a 208-volt three-phase panel. The voltage to ground is 120 volts, meaning we're still sitting in that first column of 0 to 150 volts. But wait, you're mounting it on a cinder block basement wall. Well, the NEC literally considers concrete, brick, and tile walls to be grounded surfaces. So, standing between the live panel and that concrete wall instantly triggers Condition 2. Because the voltage to ground is under 150 V, your required depth is 3 feet. But depth is just one piece of the puzzle, right? What about height? Well, the working space headroom must stretch from the floor, or grade, up to exactly 6.5 feet, or the height of the equipment itself, whichever is taller. This is just to ensure that a qualified person can stand up straight and work safely without smacking their head on live gear.
And then there's width.
Your required side-to-side working space is the width of the equipment itself, or exactly 30 inches. Again, whichever measurement is greater. You can't just squeeze a panel board into a tiny 20-inch wide closet alcove and expect to legally or safely work on the thing.
Let's keep it moving. Part 4. Installation specs.
Okay, test riders absolutely love this one. According to 110.14c, if your overcurrent protection device, so your breaker, is rated for 100 amps or less, you gotta use the 60 degrees Celsius column for your conductor ampacity, unless the equipment is specifically listed and marked otherwise. If the circuit is rated for over 100 amps, you bump up to the 75 degrees Celsius column. The trap here, the temperature rating is completely driven by the breaker size, not by the insulation rating on the wire you're holding in your hand.
Remember that continuous load thing we talked about earlier? The whole 3-hour rule? Well, here is why it's such a huge deal. If you have a continuous load, both your conductors and your overcurrent protection devices must be sized to handle 125% of that continuous load. You absolutely have to build in that 25% buffer, because heat naturally builds up over time when current is constantly flowing for hours on end.
And finally, we made it to part 5, exam traps.
Picture this. You're sitting in the exam room. You get a question about working space depth, and you confidently remember the 3-foot rule we just went over. But you look down, and the multiple choice options don't just ask for the distance, they're asking where the tape measure actually starts.
Here's the secret. The correct answer is always that you measure from the exposed live parts if they're exposed, or from the front of the enclosure if they're enclosed. The exam writers will totally try to trick you by saying you measure from the back wall, or maybe from the center of the bus bar. Never fall for it. You always measure from the front of the enclosure.
Let's do a quick recap of the biggest high-yield traps we've exposed today, just to make sure this is totally bulletproof in your mind. First, if a question asks for working clearance on a 120V or 240V system, the depth is almost always going to be 3 feet. Second, readily accessible strictly means no tools, no ladders, and no moving boxes. Third, those terminal temp ratings of 60 or 75 degrees are driven by the 100 amp overcurrent device threshold. And finally, continuous loads run for exactly 3 hours, not 1 hour, not 2 hours.
You're out there doing this work every single day in the field. You pull the wire, you mount the panels, and you terminate the connections. And now you have the exact code translations to match those physical skills. The code isn't just some hurdle they put in front of you. It's quite literally the blueprint for keeping you and your customers alive. So the next time you walk up to a panel, will you just see wires and breakers, or will you see the precise dimensions and code logic of a true master electrician? Go out there and absolutely crush that exam.